Okay, this is the section 2.1 pre-class notes. We're going to be doing equations, some very basic equations. So we're defining what an equation is, solutions, defining linear equations in one variable, solving those, and we're going to solve some basic literal equations. So let's talk through some definitions. An equation or equality is a statement where two quantities or um, expressions are equal to each other. Equations are employed in every field that uses real numbers. As an illustration, here is a very typical equation slash formula that people use. Distance equals rate times time. So if you wanted to know how fast you were traveling or how far it was going to be, if you knew your speed, your average speed, you could plug in and find missing pieces there. This is a chart. Sorry, it's hard to get it all on one page. I'll go slow. This is a chart that kind of summarizes some definitions for us. An equation is a statement of equality involving one variable. For us, if we call it an equation in X, there are going to be equations with multiple variables. This is just not what we're ready to get into yet, though. So something like x squared minus 5 equals 4x. A solution or a root, that is another name for solution, is a number that makes a true statement. So if you plug in 5 to the equation we just saw in the illustration above, you notice that you get 20 on both sides. 5 squared is 25, minus 5 is 20, and then 4 times 5 is also 20. So if the two sides match, that is a solution. A number b satisfies an equation if it's a solution. And then equivalent equations are when you say that one equation is equal to the next. 2x plus 1 equals 7 is equal to 2x equals 7 minus 1 because what they did here is they subtracted 1 from both sides. It is legal to add or subtract anything you want to both sides of an equation. It is also legal to multiply or divide anything you want as long as you don't divide or multiply by 0. And so that they are isolating this down and solving for x. And to solve an equation means to find all possible solutions. This is something we'll see a lot more of in another section, but if you have two factors set equal to 0, either what makes the first one 0 is the answer or what makes the second one 0 is the answer. That is called the zero factor property. An algebraic equation in X contains only algebraic expressions such as polynomials, rationals, radicals, and so on. An equation of this type is called sorry, I don't remember what this blank is supposed to be. Oh, it's conditional. Sorry. Took me a second to remember what the blank was supposed to be. This is a conditional equation if there are numbers in the domain that are not solutions. For example, x squared equals 9 because it's conditional since the number x equals 4 is not a solution. And then if every number in the domain is also a solution, that is when it is called an identity. Most people don't use the word identity. They use all real numbers are solutions, or they may have seen something like infinitely many solutions. So identity is a better way to describe that mathematically, though. Okay, linear equations. Linear equations are where you have the standard setup of x to the first power, and there might be multiple steps to isolate the x on one side by itself. They use ax plus b as a generic setup, but a linear equation has x to the first power. And here are our general steps to solve, and then we're going to get into our examples. First thing you want to do is clear your equation of any fractions, if they exist, just because that makes life easier. Multiplying by the LCD will help you with that. If you see any distributive properties, you'll want to do that next. If you have like terms on individual sides, like two things on the right side that are like terms, or two things on the left side that are like terms, you want to combine those next. Here's where we start using adding, subtracting, multiplying, and dividing. If you have X is on both sides of the equation. You want to get them all on the same side. So we add or subtract to move entire terms from one side to the other. That means that's the addition property, which is also subtraction. And then we isolate the variable, which means we disconnect coefficients from the variable by using either multiplication or division, which we call the multiplication property. And then check your answer to make sure it makes sense, especially when we do word problems in the next section. Okay, so let's look at this first example. This is a pretty basic one. There's no fractions. You can get rid of the decimals if you want. It's not required. I actually usually just work with decimals. They're not the worst thing that could happen. So if we wanted to work this out, get my equation editor up. 0.3 times 3, we would use our calculator or do that in our head. That is 0.9x, or excuse me, not x, plus 0.3 times 2x would be 0.6x. Bring down the plus 1.2x and the equal to 3.2. No distributive properties anymore. Now we do note that we have x's that are both on the same side. These are both on the left side together. So you don't need to do any adding or subtracting when they're on the same side. All you need to do is combine the like terms. Since they're both positive, we're just going to be adding. So if we add those together, so we have 0.9 plus 1.8x equals 3.2. Okay, now we have the x over here on the left side, but this 0.9 does not have an x, so we want to get rid of it. To get rid of a positive 0.9 and move it completely to the other side, we subtract it. Now, you should be at a point in your math career where you can write it like this without showing me subtraction underneath. All I did was move the term from the left side to the right side, and I changed its sign once it arrived on the other side. And then 3.2 minus 0.9 is 2.3. So I have 1.8x equals 2.3. When we go to divide, because we want to disconnect that 1.8, which is being multiplied by that, you get 2.3 divided by 1.8. Now, let's talk about this. We do not leave fractions with decimals in them. So here's a trick that I picked up just by learning how things work. If you move a decimal on the top of a fraction, you have to move the same amount on the bottom. So we move them both over 1 to the right. You get the fraction 23 over 18, which is a integer ratio, which is what you want. You do not want decimal ratios. So 23 over 18 is our solution. Now, if we wanted, we could check that. I'm not going to, but we could check that to make sure it works by plugging it in for x and making sure the left side equals the right side. I might check on this next one, but I didn't want to do it on that one. And you don't have to check on your work for the test, but it never hurts to check. So on this next one, we have to remember that when you see something like x plus 5 squared, that does not mean you square the x and the 5. That means you have to write it out as x plus 5 times x plus 5. So you have to FOIL it, plus 3 equals x minus 2 times itself as well, so x minus 2. I do not know why that is underlined. There we go. Okay, so when we work this out, we need to FOIL those. So x times x is x squared. 5x, so plus another 5x, plus 25, plus 3. On the other side, we get x squared, because x times x. We get a minus 2x and another minus 2x when we FOIL. And negative 2 times negative 2 is positive 4. Combining like terms on both sides, we would have X squared on the left plus 10x plus 28 equals x squared minus 4x plus 4. And this is one where students would think, oh no, I'm going to have to factor something because they see the x squared, which is usually true. If you see an x squared, you have to factor. Or you have to try to solve it a different way if you can't factor it. But x squared, when you go to move it from one side to the other to join each other so that they can be like terms, they would actually cancel out. Because you'd be subtracting x squared from both sides, so it cancels out on both sides. So you actually are just left with the other coefficients and their variables. So now we would want to add 4x over to be with 10x. And we would want to subtract 28 over to be with positive 4. And that gives us 14x equals negative 24. Final step would be to divide and then reduce our fraction. So we would have had negative 24 divided by 14, but both of those are divisible by 2, so this would be negative 12 divided by 7. Okay. Now, if I wanted to, I could check that out by working it back into the problem. So I'm just going to show you on my calculator that this actually works. You don't always have to check on paper. So I'm going to type in, and this is going to go to decimal form, but I'm just not going to clear anything out so that I can keep an accurate answer. So we're going to have 12 divided by 7 as a negative fraction plus 5. Then we're supposed to square that because it was squared, and then plus 3. So notice you get this really long decimal on the left side, 13.795918, blah, 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 blah. We want to check to see if that's what we also get on the right side. So again, we would have 12 divided by 7, but that is a negative fraction, minus 2, and then if we square that, you get the 13.795918, blah, 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 blah again. So this does work out as the correct solutions because the left side and the right side are exactly the same. Okay, we're finally on a fraction one. When you're dealing with fractions, you want to try to get rid of them if you can, and one way we do that is to multiply everything by the LCD. In this case, the only denominator we see is 3, so we're going to multiply everything by 3. How you would write that out to show your work, you would do 3 times the first term, and then 3 times the second term, so put that right in front of the 1. 3 times the next term, plus 3 times the last term. Okay, on the ones that have the denominator of 3, the 3's are going to cancel, so this just leaves me with a 5 and an x. 3 times 1 is 3. You do have to work that out. 3 times 4 is 12. The 3's will cancel on the last part, which just leaves me with a 2 and an x. So once you clear out the fractions, it makes the equation a lot easier to solve. So we need to get our fractions to have x's and numbers on the same sides together. So I'm going to subtract over 2x, but I'm going to add over 3 because you do opposite operations. So 2x was positive, so to move it, it becomes negative. 3 was negative, so to remove it, it becomes positive. And then we get 3x on the left side equals 15 on the right side. And this one will divide evenly. When you divide by 3, you'll get x equals 5. Okay, so that leads us into our last topic, which is the literal equations. Formulas are pretty much just relationships between quantities. Where letters represent different quantities, like t equals RT was distance equals rate times time. What we usually do with these first is, well, one thing we can do is we can plug things in and solve for different letters, or we can just rearrange the equations for different letters. So notice this says take this equation or formula and solve it for the letter C. To solve for something, you have to have all of that letter on the same side. So my first step here would be to move the PC over to B with the other thing. So I'm going to subtract it over to the left side. Now everything on the left has the letter C. The reason we want to do that is because now that everything on the left side has a C, you can pull it out like a GCF. So C, D, take away the C would just be D. C divided by itself is 1, and PC divided by C would just be P. And then notice your final step here is that C is connected to that big parentheses by times. So if you want to get rid of times, you divide. So you're going to have N divided by this big, long parentheses. Now, I will tell you, WebAssign is picky about letters. So if they have capital letters, make sure you use capital letters. It is one thing it is picky about. Okay, so we want to take this next one. We want to solve for R. So it looks like we have one term that has R in it. So we want to get that to be on the right side by itself. Might as well just keep it over on the right. So I'm going to subtract the capital P by itself to the left side. Excuse me. So I have this. And then notice that R is connected to P and T both by multiplication. You can divide both of them out at the same time. So on the left, you're going to have this big A over P, or A minus P, all over the RT, which is what we're, or not the RT, sorry, the PT, which is what we're dividing to the other side. And it keeps wanting to make it a capital T. There we go. And that would equal R. So these are not really hard. You just have to ask yourself, how do I isolate the letter? So subtract the P over and then divide by the P and the T. Okay, so look at our last one. We're trying to solve for H. The trouble with this one is the H is inside the parentheses. Usually if that happens, you have to get rid of that parentheses to begin with. So I'm going to just distribute that 2 to everything so that I no longer have a parentheses. And it's underlining everything again. Hang on just a second. We do not want underlined. We do probably want italicized. Okay, so now 2 terms have H in them, so we want to leave those on the right side and get anything that doesn't have H to the left side. So 2 minus 2LW would go on the left, and then 2HW plus 2HL can stay on the right. We want to pull the H out of that common pair. You don't want to pull the 2 out. We want to leave that alone. We only want to isolate H. So we're going to pull H out, and that would leave us with 2W plus 2L. And then our final step to get H by itself would be to divide that parentheses over to the other side. So on top of my fraction on the left, I have my S minus 2LW that is supposed to be capital, and then on the bottom I would have that 2W plus 2L that's divided over from the right side. There we go. So 2W plus 2L, and that whole thing would equal H. All right, that is the end of this section.